Hi, this is your Unit 1A test review. I'm going to go through every question that you have on the review. Please make sure that you're checking your answers against mine to make sure that you have all the correct answers. So the first one here, it says circle all the irrational numbers. Remember that when we're thinking about a real number system, we have two sides to our real number system. If we think of our graphic organizer we made, this side, all of my numbers are rational. Had all of our circles on this side that we did, and on this side, everything is irrational. So also we have to think of our definition. Irrational numbers, they're non-terminating, they don't end, and also they are non-repeating. They also have to not repeat. So if they do repeat, they wind up being a rational number. So we're looking for non-terminating and non-repeating. This one is a repeating decimal here, so that one does not count. Pi, we know, is our famous irrational number. This is a fraction, so that is going to be rational. The square root of 2, remember, if it's not a perfect square, it's automatically going to be an irrational number. This one here, when we're looking at this has a repeating decimal. It's 1, 3, 1, 3. We're going to continue that same pattern of 1, 3, 1, 3. Even though it doesn't have the repeating bar, it does repeat. So therefore, it's a rational number. Remember, rational repeating. This one is a little bit different. This one here has 8, 4, 7, 2, and then dot, dot, dot. I have no idea what the next numbers are going to be. So I would circle this one because this one would be irrational. 22 over 7, remember, is pi. Again, that's our approximation for pi. That's also irrational because when you do the division, it becomes a decimal that never ends. This is a rational number because it's a fraction. And remember, this square root here, we actually have to do the square root, which makes it 11, and 11 would be a rational number. Number 2, now it says to circle all the rational numbers. So this time we're thinking about the things that are on the left side of our graphic organizer. So 0, obviously, that's a whole number. So that one is circled, it's rational. Here again, this is 3, 4, 3, 4. That's repeating, rational repeating. This also is repeating because it clearly has the repeating sign with the bar over the 21. This is also rational because it's a decimal. This is rational because it's an integer. This is rational because it's a fraction. Even though it's negative, it's still rational. 3.14, remember, this is rational. We're not saying that's pi. That is just a decimal. 3.14 done. So that makes it a rational number. This one here, I have no idea what that pattern is. So this is not a rational number. And the negative square root of 25 would be -5, and that is also a rational number. So all those are rational. Number 3 says to select all the sets to which the number negative square root of 144 belongs. Okay, again, I have to solve this. 12 times 12 is 144, so it's -12. And I want to go down my list. -12 is a real number. That is a true statement. It's a real number. Every number is a real number. It is not irrational, so that's not one of the things I'm going to check off. It is a rational number. That is true. It is an integer. -12 is a negative number, so that's our integer. Whole numbers and their opposites. It is not a whole number because, again, it's a negative number, so it's not the whole number. And it's also not a natural number. Number 4, it says, which cannot be used to describe the number 14 over 7. Okay, well, again, I have to simplify it. 14 divided by 7 gives me 2. So this is the number that I'm actually talking about. And I'm going to go through and just sort of do a true-false in front of these. 2 is a whole number. That is a true thing. I'm going to check it off, okay? We have 2 as an integer. Yes, it is. 2 is irrational. No, it's not. Irrational numbers, again, are non-terminating, non-repeating. This ends, and it's a regular number, so that doesn't seem to fit. Is it a real number? Yes, it is. So the odd man out, that's the one that's going to be correct. They're asking for which cannot be used to describe that number. It is not irrational. Number 5, which classification of the real number system describes all numbers in the set below? The first one to do is sort of, because I see that I have right here with pi, I have an irrational number. So if the rest of these are irrational, then that makes it my answer be A. However, I'm going to look at the very next thing right here, this 1 over 9, or even this -3.75. these two are both showing me that these are rational numbers. These are my decimals, my fractions. Okay, so immediately, since I have something on the left side of being rational and something on the right side being irrational, my only classification for all these numbers is real numbers. Because if I have both rational and irrational in the same set, that's as small as I can get, is real numbers. Number 6 says, what subset of the real number system is 4? Well, 4 has a lot of categories. It's going to be everything from a natural number all the way up to a real number, also without being irrational, of course. So I'm going to call this rational for now, and you'll kind of see why. But if I need to, make sure that you also would say that it is also natural or counting. It's also a whole number. It's also an integer. Okay, so the other thing now, the second part of this says, what subset of the real number system is a square root of 99? Well, automatically I can see that this is not a perfect square. That automatically makes this irrational. So this is an irrational number. Now the third part of the question here says, which subset of the real number system does the product of these numbers belong? Well, product means I'm multiplying. And here's the thing. Anytime I take a rational number times it by an irrational number, I'm going to wind up with an irrational number. So that's just a little rule of thumb. It also would be the same if you were adding. Anytime you're adding a rational number and an irrational number, you're going to get an irrational number. Number 7, why is 0.184 ... considered an irrational number and not a rational number? Explain in your own words. Okay, well, this has a lot of different ways you could explain it, but this is my basic definition of it. It gets back to my definition of an irrational number. So I know that irrational numbers, these are non-terminating, non-ending, in other words, or never-ending, and they are non-repeating. If they are not going to end and they're not going to repeat, that makes it an irrational number. So that would be my way to explain it. Number 8, which of the following sets contains only rational numbers? Okay, so again, thinking of my real number system, I'm thinking of everything on the left side of my graphic organizer. So I'm looking for rational numbers. So what I'm going to do is I'm just going to kind of check them off as I go, if it's rational. This is rational because, again, it ends. 3.14, it's done. Square root of 100 is 10. 10 is a rational number. 4, 5, 4, 5, that's going to continue 4, 5, 4, 5. That's repeating. If it's repeating, it's rational. So I'm checking that one off. And then this here is a negative square root of 25. That's going to be negative 5. That's also rational. So far, this is the answer I like. But I don't ever stop there. I look at my other choices and make sure I didn't make an error. So now I'm looking to see if I can find in these other sets, if I find anything that's irrational. Well, right away in B, that's irrational, so that's out. And so B is out. And D is out for the same reason. That's irrational, that's out. So now I'm looking at C. And to take a look at C, I see right here that this number has 9352 ... That means it's not repeating because it doesn't tell me that pattern there doesn't repeat. And so since that pattern doesn't repeat, that's out, which makes this out. So A is my correct answer there. Number 9 asks, which of the following is between 21 and 22 as far as your answers? Now remember, when you're trying to find the square root of something that's not a perfect square, it's always going to be between two consecutive whole numbers. And that's what 21 and 22 is. 21, and then the next number is 22. That means consecutive. They're both whole numbers. The way I would do this is I'm going to take 21 times 21, and when I do that math, I get 441. That's 21 times 21. Or 21 squared. And then I'm going to take 22 squared, or 22 times 22, and I get 480. So now all I'm looking for is which one of these numbers right here are between 441 and 480. Well, this one is too small. This one looks good because that's right after 441. This one is 440, so that's out. And 45 is too big. So clearly my right answer is this right here. So the square root of 444 is somewhere between the square root of 441 and the square root of 480, which makes it somewhere between 21 and 22. That's what we're looking for there with that. Number 10 says the area of a tablecloth is 36 square feet. What are the dimensions of the tablecloth? Okay, so we're looking again. I can see that it says square feet, so it's an area problem. But what I'm really looking for is these answers here. This is a 4 by 4. Well, 4 times 4 is 16. 16 does not equal 36, so that one's out. 6 by 6, 6 times 6 is 36. All right, so far I like this one. 8 by 8, that's going to be 64. And 12 by 12 would be 120. 12 by 12 is going to be 144, sorry. So clearly the right answer here is the one that's 36, so it is B. B is the right answer for that one. Number 11 says to identify all the numbers that are perfect squares. Again, my best advice to you when you're trying to do this is I would actually make a perfect square chart. So I'm literally going to start with the number 1. 1 times 1 is 1. That means the square root of 1 is 1. The next one, 2 times 2 is 4. The square root of 4 is 2. Next one would be 3's. So 3 times 3 is 9. Square root of 9 is 3. And I would just keep doing this all the way down until I found out all of my square roots that are listed there. So I know that 25 is 5 times 5, so I would check this one off because I want to know the numbers that are, watch the wording, I'm looking for the numbers that are perfect squares. So square root of 25 is 5. The square root of 136 is not a perfect square, so that's out. The square root of 81 is 9 times 9, so 81 is a perfect square. The square root of 221 is not a perfect square, and the square root of 324 is 18 times 18. So those would be the only things that I would check off to show the numbers that are perfect squares. Okay, for this next one, it's very similar to the last one. They're asking the square root of 50 lies between which two consecutive whole numbers. So again, I'm looking for the squares of these numbers to see if they're close to that 50. So when I look at the first one, 7 times 7 is 49, and 8 times 8 is 64. Well, 50 is in between those numbers. So this is actually my correct answer here. And for the essence of time, I'm just going to go ahead and go on from here. But all you would do is make sure the other ones, 8 times 8 is 64, 9 times 9 is 81, and you're just going to keep working that out until you find where, again, 50 would go between. This is the only thing it was going to go between. The square root of 81 is, well, again, we just said a second ago that the square root of 81 is 9, but remember that whenever they're doing this, they're asking you, there can be two answers. It can be both the positive 9 and the negative 9, because a negative times a negative is a positive. So negative 9 times another negative 9 is going to give me a positive 81, in which case then C is my correct answer for this one. Number 14 says to identify all the numbers that are not perfect squares. So the same principle applies. 7 times 7 is 49. That is a perfect square. 729 is the square root of 729 is going to be 27. And so that also is a perfect square. The square root of 122 is not a perfect square. So this is what I'm checking off. The square root of 198 is not a perfect square, and so I'm going to check that one off. The square root of 441 is 21, so that is a perfect square. Again, make sure you're watching your wording. This time they're asking are not perfect squares. So be very careful of wording on your test. Okay, number 15 and 16, I'm actually not going to do them here on this page. I'm going to show you on the next page in just a second. But they're asking you to give examples of each of the following properties. Now you have graphic organizers and worksheets, etc., that show you all these different properties. Make sure that you can talk about each kind. You're talking about commutative property of addition and multiplication. You're talking about additive inverse, distributive, multiplicative identity property, multiplicative inverse property, multiplicative property of 0, additive property of 0. And then again, when you get to associative property, it's of addition and multiplication. Now I'm going to show you on this page about that part, because this will be some examples, and also at the same time I'm going to show you how I would make sure that I answers number 17, 18, and also 19 and 20. Because on this page, what they're asking me to do is it says to choose the correct answer or the correct letters that matches the statement. You must select all the correct answers. So before they're asking me in 17 is to look for anything that says is commutative property, and then in 18, anything that is distributive property. Before I even answer it, I'm going to go up to each of the examples and I'm going to classify what they are. And that's really the best advice I can give you when you see a question that looks like this. I would label what every one of these is and be very specific. Even though they're only asking for a commutative property here, is it of addition or is it of multiplication? So I want to make sure I know both those. So for A, we have a parentheses A plus B plus C, and then we have A plus, and then the parentheses are B plus C. So I can tell that the thing that changed here was my parentheses. So this is my associative property. So I'm looking for associative property, and this is of addition because everything is addition. So that's associative property of addition. For B, it looks pretty similar. I have A, B, C, but then I have C, A, B. So A and B stay the same. This is like saying one number here. That's a number and that's a number. The only thing that changed was my C went from the back to the front. So this is my, it changed the order, the CO. So this is my commutative property. And again, this is commutative property of addition. For C, again, I have parentheses, but let me see what's happening. I have 3, 7, 4. I have 3, 7, 4. Again, I have 3, 7, 4. So the order did not change. It looks like it's going to be associative. I have parentheses 3, 7, and I have parentheses 7, 4 there. So this is associative property, and this is going to be, though, of multiplication because it's all multiplying. My D choice over here, I have A, 8D. I have A, no, I have 8AD. So here they switched. So since the order switched, again, this is change orders, so this is commutative, and it's a commutative of addition. For E, when I'm looking at this, I have, again, all this is like saying one number and I'm adding 0 to it. And now I get that same one number that's there. So this is my additive identity. Because remember, it's keeping its identity. 15 plus 10 is still 15 plus 10. This next one here, I have 3, 7, 4. I have 7, 4, 3. So clearly my order changed here. And it looks like what they did is they put the 3 at the front here and the 3 at the back here. So this is my changing order, commutative property of multiplication. For G, I have 6AB and I have 6AB, but it's grouped differently. So this is my associative property of multiplication. The last one here, this one is distributive. 9 went to A, and then 9 went to 4. So it became 9A plus 36. This is distributive property. All right, now that I've done all that, now I can go back to the question. And also, again, this gives for the previous question, it gives me some examples of all these different kinds of properties. So from the statements above, choose all that demonstrate the commutative property. It's not being, it doesn't matter. I want either both addition and multiplication. So as long as it says commutative, I'm writing it down. So it's not A, it is B. So I'm going to write the letter B. It's not C, it is D. It's not E, it is F. And it's not G, and it's not H. So there's my answer, B, D, and F. When you do this, please put your letters in alphabetical order. It makes our life easier. Then we have, from the statements above, choose all that demonstrate the distributive property. Well, doing this, there was only one, and that's H. That is distributive. This is a similar question right here. This one now is, again, I'm going to do the same thing. This is a -1 plus a positive, or +1. This is my additive inverse. Because remember, when I add my opposite numbers, or my inverses, then I get 0. This is my additive identity again, because 7 plus 0 is 7. It retained its identity. This is my multiplicative identity because I'm multiplying by 1. The next one, the same thing. It's also a multiplicative identity. This next one here, E, this is a multiplicative inverse. This is like saying 7 over 1 times 1 over 7. So this is my multiplicative inverse. A plus B equals 0. This is a tricky one because when I look at this number here and this number here, they must be opposites if this is my answer. So this is my additive inverse. That's going to be my additive inverse. Here again is additive inverse because this time it shows you with the 8 and the negative 8. This is like saying A is 8 and B is negative 8. So this again is my additive inverse. And then H is my additive identity. Okay, so now that I've done all that, now I can actually read the question. From the statements above, choose all that demonstrate the identity property of multiplication. All right, they're getting very specific. I can only do the identity of multiplication. So it's even though A is out, B is identity, but that's additive. C is in multiplicative identity. Okay, and then D is in multiplicative identity. Multiplicative inverse is not, additive inverse, inverse, and then I have additive identity. So it's only C and D. The next one says, from the statements above, choose all that demonstrate the inverse property of addition. So additive inverse is what we're looking at. So A works, and F works, and G works. So those are my answers there for that. So this was your review for the Unit 1A test. I hope that you're studying hard, and I wish everybody a good job and good luck on the test.